A student on a bicycle can move away from traffic lights, you got that, quicker than a truck. But after some time, the truck will overtake the bicycle. So what you need to picture here is a bicycle and a truck stopped at traffic lights. You got that? So a bicycle and a truck stopped at traffic lights. When the traffic light turns green, the bicycle will go past the truck. But after some time, the truck will catch back up with the bicycle. So,
Is that overtake?
Yeah.
Like same speed or push the truck?
Overtake means passes out, yes? Assume that the student, okay, so the student on the bicycle accelerates at 2 for 6 seconds and then continues at a constant speed. So if I was to draw this is what the bicycle looks like. For 6 seconds, the student will accelerate and then they reach their maximum speed and then continue at this speed. So that's 6 seconds. This is 2 meters per second squared. And then this we don't know. This is the speed. So that's the bicycle. So first question, what is the speed of the bicycle? So how can I find the V here? What formula? V, come on, wake up time. V equals U plus AT. So in this case, it's 0 plus 2 times 6, which is 12 meters per second. So we can mark off 12 meters per second there. What's wrong, Andy? Can't understand what?
I finished it, yeah, I can't understand why am I doing it.
You finished it, but you can't understand what you're doing. Do you understand now?
No, I don't understand the working, but I know the answer.
I'm not sure what you're saying. I'm going to continue. Yes?
I can't understand what am I doing, but I just he didn't know what he did. So.
But did you get the right answer?
Yeah.
But you don't know what you did?
Yeah.
Interesting.
I did, I think, 2 weeks ago.
Oh, okay. Right, you distracted me, Andy. Now, next one. Calculate the total distance of the bicycle in 10 seconds. So how do I find distance now? It's the area. So sorry, let me just try and mark this together. This is the answer to A part 1. Is that 12 there? Okay. Now, A part 2, maybe I'll write it here. A part 2. So, distance will be the area. What's the area of the triangle? It's a half.
1.5 meters.
Yeah, so what's the base here? 6. Multiply the height. What's the height? 12. And then it's the rectangle piece at the end. So what's the base? 4. And the height? 12. Okay. So what's that, like 96 or something?
I'm assuming you can just use the formula.
84. No.
You can?
Mm-mm.
Why not?
Yeah, good question. Why not? You tell me why not.
We don't have enough information.
Oh, you do. Somebody please tell me why we cannot use the formula S equals UT plus a half AT squared on this total journey.
Because it's not uniform.
Yeah, you can't because, are you listening? Everybody, that's important. You cannot use the formula S equals UT plus a half AT squared because the acceleration changes. So you can only use the formula on parts where the acceleration is the same. But it goes from 2 to 0 acceleration. Okay? So don't use the formula, you have to use the graph. Or use the formula twice in each part. What did you do, Andy? Did you use the formula twice or did you use the area?
I get that.
Oh, sorry, I forgot you don't know what you did. Yes. All right.
I think I just imagine.
You used your imagination.
Yeah,
Great.
I just like, because the accelerate, so I maybe go up twice.
Oh.
Because after that was speed times time, so I get the total distance, and then the first one I get already. Like just
Yeah, I don't know what you did either. Sorry.
I was, almost don't know what I'm doing.
Okay, good. Calculate the acceleration of the lorry, of the truck. So the lorry starts at rest, and it too accelerates. But notice how its acceleration is constant. For 10 seconds also. Now, here comes the key part. After 10 seconds, the lorry and the bicycle are at the same location. So it starts off like this. Bicycle goes ahead, then lorry catches up. 10 seconds. So what can you say about the distance the lorry has travelled?
Same as
Same.
84.
It's the same as the bicycle, because they both travelled 84 metres. So when I draw the lorry, I can know that this here is 84. Okay? So, and the acceleration I call A.
It's A about T, right?
Yeah. Okay, he wants the acceleration. So what formulas could I use? Do I know the V? No. Do I know the U? Yeah, 0. I know the T, and I know the S, so I think the best one to use would be S equals UT, which is 0, plus a half AT squared. So in other words, 84 would equal a half AT squared, which is 100. So 84 times 2 divided by 100 is 1.68. What, Andy? And then the final part for this is what's the speed. So how can I find the velocity of the lorry?
Just V.
V equals U plus A times T. So that's something we can just write down in our head. Simple calculation. 16.8 meters per second. Now,
V route plus 1. And then it's right.
we're too busy sleeping, was it?
No. I was
Now listen carefully. I have to go back up to the top anyways. I find this question a bit odd because the B part is what I did at the start. Draw the graphs.
Yes.
But I think it's much easier if you draw the graphs at the beginning. So sometimes you get this in the exam. Not often, quite rare. But sometimes, in my opinion, it's easier not to do the questions in order. Just go with what seems like the easiest order for you. So for me, with these time velocity problems, the first thing you should do is draw the graph if you need to. So in fact, this is the answer to B part, and then this graph here is the answer to B part as well. Where it says draw the graph for the bicycle and the truck. Now what part do you look there?
this one. Second one.
How far down? Here?
No. Yeah.
Here? Hurry up.
So we need to combine the two.
Did they ask to draw it?
Bicycle and truck on the same.
Draw a sketch of the velocity against time for. Yeah, it seems like they want it on the same one, although they're not clear on it. They say on the same axis. So, okay, if you want, you can put them on the same one. Let me just, well, I'll do that in a minute once you've done it. Actually, you know what? I'll just bring this one up to the top. So, what was the V for that at the end? 16.8. So at the very end it'd be like up here, 16.8. So, I know it's not to scale, 16.8. And that one is the truck, and then that one, the black one, is the bicycle.
Do we need to calculate the axis?
I don't know what you're asking me.
Which means the truck will be 12 speed, the speed will become 12 meters.
No, they don't need to calculate that, no. Yeah. Go down. Okay. Well, here, let me just stop the recording while you're writing it.